circles, working out the coordinates for the center of a circle and the radius of the circle by using the completing the square method. If you take this general equation of a circle that's not centered on the origin, you can expand the brackets to get x squared plus a squared minus 2ax plus y squared plus b squared minus 2by is equal to r squared. And then rearranging the terms, x squared plus y squared minus 2ax minus 2by, and then all the constants, plus a squared plus b squared minus r squared is equal to 0. Now sometimes you're given the equation of a circle that looks similar to this, and this equation here is written in a similar form. So you've got the x squared term, you've got the y squared term, you've got the x term, you have the b term, not the b term, the y term, and then the constant here represented by the sum of all these constants here. So if you're given an equation of a circle in this form, how can you state the coordinates for the center of the circle and the radius of the circle? If the equation is given in this form, then stating the coordinates for the center, which is based on these values here, and the radius, which is right there, is simple. But in this form, it takes some more working out, and we're going to use the completing the square method to work from here back to this form. And then we can easily state the coordinates for the center and the radius. Okay, so for this circle here, if I keep the x terms together, so x squared minus 4x, and then I'll keep the y terms together, plus y squared minus 10y, and any constants I'll move to the right hand side of the equation, so that minus 20 becomes plus 20 on the right hand side. And now I'm going to complete the square for the x terms. So I've got x, half the coefficient there is minus 2, and that will always be a minus there, and minus 2 squared is 4, so that goes here. And then I'll do the same with the y terms. Half the coefficient here is minus 5, that's always a minus here. Minus 5 squared is 25. In between here there's a plus, and that's equal to 20. And now, taking all the constants to the right hand side, on the left hand side that leaves x minus 2 squared plus y minus 5 squared is equal to 49. So the center of the circle will have coordinates, so that's minus 2, so the opposite sign to that would be plus 2, that's minus 5, the opposite to that is plus 5. The 49 is r squared, so the radius is equal to 7. So this circle here that has this equation has its center at the point 25 and has a radius of 7. So going through the method again, first step, separate the x and the y terms. So I've got the x terms together, got the y terms together. Any constants, move them over to the right hand side of the equation, and then complete the square for the x terms, complete the square for the y terms. Any constants, move them over again to the right hand side, and then you can easily state the center and the radius. Now in this method you need to know how to complete the square, and that's a key skill that you need for C1 anyway. An alternative way of doing this, so if you start off with an equation that's in its expanded form like this, you can use this. So there's the equation of your circle, which has its centre here and radius equal to this. You need to memorize all this. It's just more stuff that you need to memorize, and there's no real need to, because you already know how to complete the square, and you can quite easily apply this method.